So how do we write a ratio? So when you're writing a ratio comparing two different quantities, it's important that the units are the same. Let's look at an example and see why. So a cactus is 15 inches tall. An oak tree is 118 feet tall. What is the ratio of the cactus height to the height of the oak tree? So let's set it up. We have the ratio of the cactus is 15 inches tall. And we have the ratio of to the oak tree, which is 118 feet tall. So this gives us a comparison, but it's very specific. It's in inches and feet. I should be able to use my ratio to compare the two quantities, in this case the cactus to the oak tree, in any circumstance, given any unit. I should be able to say this many meters of a cactus is equal to this many meters of the oak tree. So to do that, I need to get rid of my units. And the way I do that is by putting them into the same units. So here I have inches to feet. So I'm going to cancel out my feet and turn it into inches. So I know a lot of you are enthused about unit conversion. So here's your time to shine, right? We want to cancel out feet and turn it into inches. So feet's in the denominator. I'm going to put feet in the numerator. And I want to turn it into inches, so I'll put inches in the denominator. And then I need to figure out my conversion factor. So I have it on the side here. There's 1 foot is equal to 12 inches. Hopefully you knew that. So we can say that 1 foot is equal to 12 inches. And now we can cancel out. We can say the feet unit cancel out, and our inches cancel out. And now we're left with the real ratio, which is 15 over 118 times 12. Now I'm going to cancel out some common factors. 3 goes into 15 5 times. 3 goes into 12 4 times, which gives us 5 as the numerator and 472 in the denominator. And now we can leave our ratio. It's 5 to 472. So notice that this new ratio is unitless. So basically I can compare cactus to the oak tree using any unit I want, and it's going to still maintain the ratio of 5 to 472. So one other type of problem you'll see when you're writing ratios is dividing a total into a specific given ratio. So in this example, a baseball team played 145 games in a season. The ratio for games they won to games they lost was 3 to 2. How many games did they win? So we know that the wins to losses, I'm going to write wins to losses, is 3 to 2. And we know it's not actually 3 wins and 2 losses because together that's just 5, and we know they played 145 games. So this goes back to why it's important not to have units with our ratios, because we can say that ratio is maintained no matter how many games they played. So we can say 3x compares to 2x, right? So for every multiple of games that they played, it's going to maintain a 3 to 2 ratio. So we can say that 3x plus 2x equals the total number of games, which is 145. That tells us that 5x equals 145, which we can then say x equals 29. Now that we know that x is 29, we can say that the number of wins is 3 times 29. So we can say 3 times 29, and that will give us 90 minus 3 will give us 87 wins. And we can also find the losses, because losses are just 2 times 29. So let's just do 2 times 29. And 2 times 29 we have as 58. And if we put these two together, if we added up 87 and 58, we should have the total number of games, which we do, because 8 plus 7 is 15, and 8 and 1 is 9 plus 5 is 14, so that gives us 145 games.